Good morning again, Year 8. Thanks for engaging with these lessons. Again, if you can please send me a little message on Show My Homework, I'll be able to see that you're accessing this lesson. I'll be able to pop you down my register and give some reward points out on Friday. Today's lesson is going to be assessed via self-marking, so all of the answers will be on the video or the PowerPoint if you've downloaded that from Show My Homework. Again, if you could please get in touch with me at red@theroyal.school if you need any assistance with the questions, and then if you can submit work via Show My Homework only, and they'll keep the two separate. Thank you very much. So today we're going to have a look at a lesson on speed, distance and time. This is the first in a couple of lessons we're going to have on compound units, which we'll get to the definition of in just a moment. So our lesson objectives, developing students are going to be able to convert between hours and minutes, which we'll go through as our starter and the first little short activity. Secure students will be able to answer simple questions on speed, distance and time, and then excelling students are going to be able to answer exam style, so more complicated contextual questions involving speed, distance and time. So moving on, our starter today, I'd like you to convert the first batch of questions to convert those times into just minutes, and then for the second batch of questions I'd like you to convert the following batch of times into just hours. You can have those as decimals or fractions, and that's absolutely fine. So if you'd like to pause the video here until you are ready to get some answers, and we'll go through those in a moment. Okay, on to the answers. So hours, 1 hour and 30 minutes in just minutes. Well, 1 hour is 60 minutes, so add on the spare 30 we've got and we get 90 minutes. For the second question, the same idea. We've got our 60 minutes from the 1 hour and the 53 spare, so we get 113. And the third one, we have 3 hours, 3 lots of 60 to 180, and then the 6 spare minutes, so 186. When you're converting the following into hours, then we need to find out how many lots of 60 minutes there are there. So if you do these numbers divided by 60, then you will get the answers to those. So 105 divided by 60 gives us 1.75. Although another way of looking at that is that if you subtract 60 minutes from that 105, you're left with 45 minutes. So we've got 1 hour from the 60, 45 spare, and 45 60ths would cancel down to be about 3/4 of an hour. So 30 minutes there, 30 divided by 60 to give us 0.5 or a half. 57 minutes, it needs to be a straight division really here, so 57 divided by 60 is going to give us that 0.95, and our 26 divided by 60 would give us 0.43 hours. That's converting our time into either minutes or hours. You need to be very careful in speed, distance, time questions that you're consistent with units. If your speed that you're after is in miles per hour, don't be dividing by minutes, be divided by decimal number of hours. So as we just said before, if our time is in hours and minutes, we might need it just in hours to run through the rest of the question, and we'd need it in a decimal form there, unless your calculator's capable of dealing in fractions. So if we had 2 hours and 24 minutes, we know that's definitely going to be, if you've got 2 hours, it's definitely going to be 2 point something, because we've already got those 2 hours given there. But we need to have a look at what does our 24 minutes give us as far as our decimal version of this time goes. Well, it's 24 minutes out of 60 because there's 60 minutes in each hour, so we could represent that as a fraction, 24 60ths. Now you can either simplify that fraction down and then turn it into a decimal if you wish, or you could just pop it in a calculator and get your decimal version of that straight away, 24 divided by 60. So that's going to give us 0.4 here. So we already know we had our 2 hours to begin with. We've now got the 24 minutes being 0.4 hours. So pop those together and we get 2.4 hours. So it's really, really important for some later questions. Consistency of units is really key. And it's probably one of the points that people have the most problems with in these questions. If they don't get an answer, it's because they've mixed up units. So I've got 3 batches of questions here. Red questions are going to be the easier ones, the orange questions are going to be the more difficult, and then the green questions are going to be the most difficult in this batch. So I'd like you to convert these following amounts of hours and minutes into just hours, and definitely just as decimals, please, for this one. So I'd give yourself about 5 minutes to do these. I would only select one set of these questions to do, depending on your confidence for them. If you want to do more, that'd be absolutely brilliant. but only ones necessary. And again, pause the video until you're ready to reveal some of the answers. Okay, answers should be as follows here. So if I run through the first one of each of these, then if you're doing the first red one, you've got 1 hour 30 minutes. So we know it's going to be 1 point something. 30 divided by 60 give us 0.5, therefore we get our 1.5 hours. If you're doing the first orange one, then we've got 2 hours and 36 minutes, so it's only going to be 2 point something, and 36 divided by 60 would give you the 0.6, and then piece those together to give us 2.6 hours. And finally the green one, we've got 1 hour and 51 minutes, so it's only 1 point something as hours, and then 51 divided by 60 would give you that 0.85. Piece them together, we get the 1.85. Again, please get in touch with me at red@theroyal.school if there's any problems with any of those batch of questions. So, what is speed? Well, speed is one of our first compound measures. So it's a measure of how far something has travelled in a given time. Now this means it's actually got two elements to it. We need the how far element, that's a distance, and we have a time that it's taken to do that. So that's our next unit. So speed actually encompasses both of those units at the same time, and that's what makes it a compound measure. Previous chapter, when we were looking at our areas, we had compound shapes where we were pieced together with more than one shape. Here we've got a compound measure where our units are pieced together with more than one measure. So speed is a measure of how far something has travelled in a given time. So it could be, for example, miles per hour, mph. We could have kilometres per hour, or we could have metres per second as the units are given there, m/s. Now these are really nice because they actually give you a little hint on how to work them out. Remember, per means divide. So what actually the unit is telling us is how to work them out in the first place. So if we were looking at our miles per hour, well, if the per bit means divide, it's actually telling us there to get that unit, we do miles divided by hours. Really straightforward. If we were looking at our kilometres per hour, then we've got kilometres / hours. That means we need to do kilometres divided by hours, and that'll get us our unit. And finally, we've got our metres per second here, and again a slash we know means divide in mathematics. So if you were trying to work out the speed in metres per second, you'd be doing metres divided by seconds. So these compound units are really nice. This will help us in our later lessons this week where we look at some more unfamiliar compound units, and you'll be able to use the same process to find out how to calculate that unit by actually looking at the measurement itself. So speed is then going to be given as distance divided by time. Now you may well have seen that as a triangle before, so this is quite a lot of crossover with science on these measures. So we can write this as a little triangle here. So we've got speed at the bottom here of the triangle, and then we can see distance at the top and then time at the bottom. And then what this means is if you need to calculate something in terms of speed, distance and time, you can actually cover up on this triangle the one that you're trying to work out. So if I was to cover up speed, then what I'm left with is distance at the top and time below, and then as we know, one thing above another in mathematics means divide, so that's telling us to do distance divided by time. But it also works if we try and do this in another fashion. If I was trying to work out the distance that something had travelled, then we could cover up distance, and we are left with speed next to time. And as we know, things next to each other in maths and algebra mean multiply. So to work out the distance something has travelled, we'd be doing speed multiplied by time. And the final version of that, if we were looking at the time that we wanted something to have taken, then we could cover up time. And you can see there we've got distance above speed. So the distance travelled divided by the speed will tell us the time taken. So it's a really nice way of arranging things. Now, having a look at some examples then of how to use this. So in many situations, the speed of something isn't constant. That means that it doesn't stay the same speed throughout its entire journey. So a person running around a track would probably speed up or slow down as they run. They might start off at 0 speed because they're standing still. They would have to accelerate to get to their sort of top running speed, and then as they get tired they might slow down a little bit, or if someone's running a long distance they might stay at a constant speed and then speed up right near the end as they're getting towards the finish line. We can still calculate their average speed, and it's using the same formula as before. So average speed would be the total distance travelled divided by the total time taken. So don't get put off by the average part if you see this in a question. It just means use the total distances and the total time taken. So 3 versions that you might want to have a look at here. Again, if you're feeling confident, you can work ahead and then unpause the video so you can hear my working out and see if you've got the answers right. If not, we can have they'll just work through these with me. It'd be worth writing down these examples, so we've got one of each type here. So example 1, a car travels at 30 miles per hour for 2 hours. How far has it travelled? So let's identify what we've got in the question. We definitely have here 30 miles per hour. So we've got a speed. It's travelling at that speed for 2 hours. So we've got 2 hours given here. We've got a time. How far has it travelled? Well, how far is asking us for a distance. So we need a distance for our final answer. We can see from the triangle here that if we're after distance at the top, let's cover it up. So distance is telling us to do speed multiplied by time. So we're going to do our 30 miles per hour times by 2 hours, which is going to give us 60. Now, just be careful of our final answer. We need to do the relevant units. If we are finding out a distance, then what distance has been mentioned already in our question? The distance would have been this part of our unit here. MPH stands for miles per hour. So our distance is just miles. So make sure you get the correct units. So on to question 2. A cyclist travels 45 miles in 3 hours. What is the cyclist's speed? So we can see here that we've been given 45 miles, so we've got a distance. We've been told that that's happened in 3 hours, so we've got ourselves a time, and we are being asked to work out a speed. Those speeds over here. So again, we can cover up speed, and we can see then that we've got distance over time. So we need our distance divided by time to get our speed. So let's run that through. Distance was 45, time was 3, so 45 divided by 3, and it gives 15. And again, remember, speed is this compound unit, so we need to piece together the units that we've got. We've got miles, we've got hours, so our speed has to be in miles per hour. And finally then, a plane covers a distance of 1,200 miles at a speed of 300 miles per hour. How long will it take to complete the journey? So we have here a distance 1,200 miles. We have a speed given to us of 300 miles per hour. So we can mark those off on our little triangle here. We've got our distance, we've got our speed, and then we are being asked how long. So how long in this case, in the context of this question, is asking for a time. Now, how long could have been the total distance as well, but in this case it's going to be a time. So we've got to work out time. So again, cover up time. We've got distance divided by speed. So distance, as we saw, was 1,200 miles. Speed is 300. So we need to do distance divided by speed. So 1,200 divided by 300. Again, if you wanted to do some mental maths on that, then you can be cancelling out a factor of 100 from each. That just gives us 12 divided by 3 if you do that mentally, and it gives us 4. And of course, if we're doing how long in time, we need to have a look at what units we had before. We were given miles per hour, so the H standing for hours there, so our time has to also be in hours to get our units correct. So that's use of our speeds and distance and time formulae. And so it'd be really useful if you can get a copy down of the triangle there, distance at the top, speed and time along the bottom. It'd be really useful to help you out with those questions. So if you could decide on how confident you feel at this midpoint of the topic, then choose red, amber or green, and we can have a go at the corresponding activity that has been attached to the Show My Homework. Again, you only need to do one of those activities. They're all the same questions, it's just varying levels of support. So the red is there for people who are not confident with this topic and need a little bit more of a hand with it. Amber is if you're fairly confident and there's a couple of hints on those questions, and green is for if you're very confident and are willing to get on with this question without any extra support. Of course, get in touch with me again at red@theroyal.school if you do need any assistance from me on this. When you're ready for the answers, pause the video and we'll go through those. Okay, on to the answers. So answers as follows. Remember, it's really important to get your units correct on this. They're equally as important as the numerical answer for these. So make sure you got both correct. And then if you're unsure about anything, again, please get in touch with me and I can give you a hand. So this is going to lead us on to the next part of the lesson, and this is going to be an extension part. So we're going to look at some exam style questions where things might get a little bit more complicated. So here we've got an extension question. It's a classic exam style question, so we're going to have a little bit more complicated work to do with our speed, distance and time, and there's a second part to the question at the bottom. So Rob is going to drive 130 miles from Hull to Liverpool. There are roadworks for 25 miles of the journey. He assumes his average speed will be 50 miles per hour when there are roadworks and 70 miles per hour for the rest of the journey. Using his assumptions, work out his journey time. And we've got a part 2 here as well. Rob's assumptions about his average speeds are too high. How does that affect his journey time? So again, if you're feeling confident with this, you might want to pause the video at this point and have a go at this question yourself, and then you can unpause in a moment and I'll talk through the answers. So how do we go about this question? Well, let's ignore the second part for the moment. We'll just do the first part, the 4-mark part of this question. So there's evidently with 4 marks going to be quite a bit of work to do. So we're looking for sort of a few steps of working out, and it'd be very important to show all of those steps. So Rob's going to drive 130 miles from Hull to Liverpool, and there are roadworks for 25 miles of the journey. So we've got our journey really split into 2 parts, the parts where there are roadworks and the parts where there is just a regular journey occurring. What have we been given then? We've been given distances, so we've been given a total distance for the journey, we've been given a distance on the road where there are roadworks, and we've been given some speeds as well. So we've got 50 miles an hour when there are roadworks and 70 miles an hour when there are not roadworks. And we want the total time. Now, what we're going to have to do is we have to separate this out into 2 separate pieces. So there are roadworks here. I'll just undergo these in purple. So there are roadworks for 25 miles of the journey. So if we just deal with the roadwork section first. So roadworks occur for 25 miles of the journey, and during those roadworks you can travel at 50 miles per hour. So let's work out the time that the roadworks will take. As we can see from the triangle, then time is going to be distance divided by speed. So going through the roadworks, we would need at 25 miles divided by 50 miles per hour, and that's going to get us our time taken. So distance divided by speed. So the roadworks are going to have 25 divided by 50, and it's going to give us 0.5. Remember, if our speed's in miles per hour, then our time is just in hours as well. Now we can start to look at the rest of the journey. What we know here though is that there were 130 miles in total. Now obviously that's not going to be the distance that we now need to travel, because 25 miles of that were roadworks. So we need our 130, and we need to take away 25. Again, excuse my mouse handwriting on this, and that is going to give us 105 miles of regular journey time, so each regular journey distance. So there's 105 miles of a regular road, and we now know that this regular road is going to be taken at a speed of 70 miles per hour. So we're going to need here, again, we're going to be doing our time is distance divided by speed, but it's now 105 miles divided by the 70 miles per hour that we can take for the speed. So 105 divided by 70 gives us 1.5 hours. Now we need then to piece those together for the total time for the journey. and then we get our 2 hours. 0.5 hours plus 1.5 hours obviously gives us our 2 hours for the total journey. So piece it together from the two sections there that had to be treated separately. And that is how we do our extension questions. So there is an extension sheet available on Show My Homework as well, and I'll get those answers up on the next slide. Again, you might not have time to complete all of the extension sheet, but just make sure you're spending the relevant time on this lesson. We can see how far people have got. So unpause the video when you are ready to go through the answers to the extension questions. Okay, answers as follows then. So number one, just make sure you're making sure you convert the units here. If we turn our kilometers into meters by timesing by 1,000, and then we need to convert our hour into seconds by doing 60 minutes times 60 seconds to get our 3,600. It's pretty close to 80 there, so let's go for a yes. Other answers, hopefully we've got straightforward for you to mark from. So if you can mark your own questions here, and we've got a final puzzle at the end, and it's a really classic question. So move on to that when you're ready. So I'm moving on. So final puzzle, this stumped a lot of people, and you might actually want to try this out on some of the adults in your household as well, because it's very, very common for people to get this question wrong. So the final puzzle: if I travel to work at a speed of 60 miles per hour, as it's early and there's no traffic, and on the way home I travel at a speed of 30 miles per hour, as it's rush hour, a bit slower and there's a lot of traffic, what is my average speed for the entire journey to and from work? And no, it is not 45 miles per hour. So this one's a classic speed distance time problem involving splitting our journey into two sections. So if you'd like to have a think about this one, and then I can run through the solution to this, and you might have to test this out. As I say, I know a few people that you know as well. So when you're ready, unpause the video and we'll go through this final answer. So it's going to be a good idea to actually imagine a distance that's being travelled here, and this will make things a bit easier to use. There's a ratio way of doing this as well, but this is probably the easier way of getting through it. So just to make my numbers really easy, I'm going to imagine that my distance to work is 60 miles, and then that's going to hit my 60 mile per hour, making a nice easy calculation, and our 30 mile per hour, they'll make an easy calculation with that as well. It doesn't really matter what the distance is, I've just picked this because it's going to make the calculations easy. So in the way to work, I would have travelled this imaginary 60 miles at 60 miles per hour. And the time taken for that, obviously time is distance divided by speed, so 60 divided by 60, it would take me 1 hour. Well, actually that's exactly what the whole compound unit there suggests. 60 miles per hour means I can go the 60 miles in the 1 hour. But what about the distance home? Well, here I'm going to be travelling obviously the same distance. If 60 miles to work, it's obviously 60 miles back from work, but we're now travelling at the 30 miles per hour. So let's do that calculation. We've got 60 miles now at 30 miles per hour, and 60 divided by 30 gives us a time of 2 hours. Well, what was the entire journey then? So if I've travelled 60 miles to work and 60 miles on the way back from work, I've travelled 120 miles. The total time taken, it was 1 hour on the way and 2 hours on the way back. So it's the total time taken is 3 hours. So what's my average speed then? The total distance travelled, 120, divided by the total time taken, the 3 hours, is going to give me 40 miles per hour. So really nice one and very well done if you manage to get that one done yourself. And then we move on to our little final step. So thank you again for engaging with the lesson, and just this final reminder here, please let me know on Show My Homework if you've accessed this lesson. Please get in touch with me at red@theroyal.school if you need help as well. Thank you very much. Have a wonderful day.